Welcome to Daily Nebraskan Dialogue, your source for on-campus debate. This week, Dr. Gerard Harbison, chemistry professor and occasional Daily Nebraskan columnist, and Monica Sanford, assistant opinion editor and columnist for the Daily Nebraskan, talk about global warming. What does the science really say? Is the end nigh? And who will think of the polar bears? All of these questions and more are about to be answered in a highly complicated and scientific way. So, as you may have noticed, it's been a little chilly. Obviously here in Lincoln, it was snowing on Saturday. In western Montana, they've had the coldest temperatures ever recorded for this time of year. In Austria, they had their earliest snowfall of all time, or at least of recorded time. And so, how does all of this apparent cooling, how does this fit in with the idea of global warming? Is this proof that somehow Al Gore made all this up, or do these short-term things really tell you anything about the trends?
Well, I'm tempted to say yes, it's all a hoax, just to freak people out. But no, the thing you have to remember is global warming, while it is accurate to some degree to say that, a better name for the phenomenon would be climate change. And that's because global warming is a product of averages. It's an average warming of the surface temperature of the Earth. So as we know with averages, there are going to be things that are above and things that are below. So what you have to factor in with climate change is that as the average temperature of the Earth increases, climate shifts and ocean currents move and the oceans and the land surface heats up and the jet stream shifts, and all of these things change in ways that we don't really completely understand because it's a very, very complex system. But at the same time, when you're looking at the statistics, you can't just say, oh, well, this is the earliest it's ever snowed in October. The planet must be cooling. That's not how they record or measure such things. You have to look at average temperatures and average atmospheric concentrations and average ocean temperatures over a pretty long period of time before you can say, oh, this is a trend. So 1 year doesn't make a trend, 5 years doesn't make a trend, 10 years doesn't make a trend, but 50 years is definitely a trend, and that's where they're getting a lot of their data, from 50 years, 100 years, 200 years, and using the ice core data back about between 400 and 700,000 years. So that's where the scientists come from when they say that global warming is happening, but you have to remember the law of averages. If a C grade is an average, that means a whole bunch of people got A's and a whole bunch of people got F's, so that we could average out at a C.
Right. So, Jerry, in the scientific community, do you think there's any real debate over kind of the fundamental principles behind the idea of man-made climate change and the threat it poses to the planet?
Yes. There certainly is. There is no debate about the fundamental physics. Essentially, the rise in carbon dioxide causes a very small amount of heat to be retained in the atmosphere. Then that heat changes the vapor pressure, the amount of water vapor in the atmosphere, and that's where the real debate lies. Because basically, carbon dioxide itself has a minimal effect, direct effect on climate. So yeah, and the sort of the newspaper versions of global warming say, well, it's the greenhouse effect, and we put carbon dioxide into the atmosphere. If we increase it, say by 50%, which we may well do in the next 50 years, then we're going to warm the Earth. Yes, that's true, but we won't directly. It won't warm the Earth very much. Now, I can go into the technical reasons for that, but it's really not relevant. The real key with global warming, the real key with physics, is what happens when you get a slight rise in temperature due to the carbon dioxide. Well, what happens is it evaporates water into the air. The water is a much more significant greenhouse gas than carbon dioxide. So water vapor is actually what's really doing the work. Now, the trouble with water vapor is that it can do two things. One is it can absorb infrared and warm the Earth. The other thing it can do is it can create clouds. When you create clouds, you basically create this white reflective blanket over the Earth, and that reflects the sun away, and it cools the Earth. So the trade-off, or the play-off between these two balancing effects for water vapor is really what makes a difference about whether global warming is going to be a problem or not. Now the problem is that physics can't tell you the answer to that. It's an incredibly complicated problem. We can do direct measurements, but we can't. There's no way I can sit down with a pen and paper or even a computer and tell you whether water vapor will amplify global warming or whether it will subtract from it.
Right. So when someone says we know global warming is happening, we know humans are causing it, the science is totally settled, we need to act now, you don't agree with that?
No. In fact, I would say there's less agreement in the scientific community than there was 5 years ago.
So what do you say about that? Because I know you've called for, really concrete action on climate change because you do believe that it's a serious problem.
Yep.
So when you hear that, what do you think?
I would agree that there is not consensus within the scientific community, but I would say it's a very small percentage of scientists who are disagreeing. And I think it's okay to question the data. I think that's necessary. However, I would not say that the data is in such a questionable state as a lot of people claim that it is. It's a simple fact that something like 7 or 8 of the last 10 years have been the hottest years on record for as long as we've been keeping records, for the last 150 years. So the fact that when you look at data like that shows, okay, 7 out of 10 of the last years have been the hottest on record, and 12 out of 15, and 15 out of 20, then you start to see some evidence that even our area is warming. And when you get reports from groups such as the NOAA, which is the National Oceanic and Atmospheric Association, they run the Weather Service, that are predicting dust bowls as high north as Kansas as a result of climate change and continued warming trends. I think we have to take this situation seriously, and we're talking about major damages to agriculture and loss of snow caps in the Rockies, and those are used for irrigation both on this side of the mountains and on the western side of the mountains. So I would say it is a serious problem. I'd say there is a great deal of consensus. I'd say between 80 and 90% consensus within the scientific community that global warming or climate change is happening and that it is a man-made event. Because when you look at these graphs, when you look at a graph from the Bostock ice cores taken out of Antarctica, which are 400,000 years old or more, and you look at the CO2 and you look at the temperature and they correlate so beautifully. I mean, you can get the raw data and run this on Excel and look at the charts, and you can manipulate the charts every which way you want to, and they still correlate so beautifully that it's pretty, to me, that's very indisputable. The fact that I can get this raw data, which is just a bunch of numbers, put it into a graph, look at it, okay. There's a pretty great deal of consensus in those models, even if there are a lot of uncertainties.
Right, so Jerry, I see you disagreeing
absolutely
there.
not. First of all, the ice core data, the problem with the ice core data is that if you plot CO2 against temperature change, in fact, the temperature changes lead the CO2. In other words, it's not the carbon dioxide causing the temperature change. The temperature changes are causing changes in the carbon dioxide levels. The ice ages were not caused by carbon dioxide levels in the atmosphere. In fact, nobody really knows what caused the ice ages. There's some theories, but they're pretty speculative. And that's one problem with the models. And for example, you would say if the models were so good, then how come they can't predict backwards? So we have this climate record, excellent climate record, for 1 million years, and the models can't get it. We've actually been cooling for about 4 years. We've been dead flat for a few years before that. Now it has been warm in the high Arctic, and that's actually something where the physics will tell you that's probably actually really happening, because in the high Arctic there's very little water vapor, and carbon dioxide is really the primary driver of global warming up there. So you increase the carbon dioxide in the high Arctic, and the water vapor levels don't change very much, and so you get a lot of warming. But down here, it's basically not happening. There's no evidence it's happening. So the thing that really annoys me is that a lot of these sort of doom and gloom forecasts. I mean, we can forecast a warming over the next few years. There's a lot of argument about how much warmer it's going to get, but the rest of the climate predictions, for example, about droughts, about the severity of storms, those are completely speculative. They're extremely model dependent, and the answer is we really don't know. I mean, climate will probably change, but we don't know how it's going to shift.